Hi class, hope everyone's doing well. I just wanted to quickly go over pointers, right? You should be using pointers in your lab assignment that will be due this week. Just want to make sure everyone has a good understanding of what pointers are and how they're used. Okay, so typically you've been creating variables and assigning them values. Pointers are slightly different in that they're referencing a variable. So you're actually pointing, it's a variable that will point, right? It's a pointer variable that points to the address of another variable or value. Okay, so the value of a pointer is an address, and that address itself holds a value. Okay, so let's do some examples to kind of have a good understanding, because this can be a concept that can be challenging to understand initially, but with some practice things will start to make sense. Okay, so I want to give you kind of the foundation. Alright, so let's include IOString, pound include string, include cmath for some math operators, and then we're going to using namespace std. Okay, so we need our int main, and we're going to return 0, and let's put a system pause in there, and cout end line. Okay, so what we're going to do, we're going to create two numbers. So we say int num1, we're going to assign that number 10, int num2 equals 20. Right, so typically what we do, we can output this number. We can say num1 equals num1 end line, and we can do the same for num2. Okay, so now that we have that, we can run it. And there you go. So it prints out what we expect. Num1 is 10, num2 is 25. So now what if we wanted to print out the address of num1 and num2? So to do that, we can say cout address. So this AND operator, and percent, this is actually, is a reference operator, right? This is actually going to, you're accessing the address of the variable. Okay, so we can say num1 num2. So now we're going to access the address of the variable which holds the values 10 and 25, right? We're going to access the address of num1, which holds the value 10, and we're going to access the address of num2, which holds the value 25. So let's see what this prints out. Okay, so we're going to run it, and there you go. You see, you get this hexadecimal number. This is actually represents address in memory. Okay, so now you can see that this is printing out the address of num1 and the address of num2, and the value at these addresses are 10 and 25 respectively for num1 and num2. Okay, so the idea with pointers is that we can assign a pointer variable which points to the address of another variable. So what we can do is we can say int asterisk. So this is the pointer, right? Pointer operator. So we could say int asterisk p1 equals to the address of num1. Int pointer p2 is equal to the address of num2. So we're creating a new variable, a new pointer p1, an integer pointer, a pointer that points to an integer, p1, another one p2, and p1 is pointing to the address of num1, and p2 is pointing to the address of num2. This is important to understand. We're not assigning p1 any value. We're not assigning p1 the value 10 or the value 25 for p2. We're just assigning these the addresses of these variables. Okay, and at that address is where these values are stored. So if we were to print out the pointers p1 and p2, let's see what we get. So let's put one more end line. So what if we were to print out P1? And let's fix this. P2. Okay, so now we're printing out P1 and P2. Remember, these are pointers to an address. So these actually hold an address, right? So it's actually, and you can see that these are the same values, right? P1 is a pointer that's pointing to the address of num1, and P2 is a pointer that's pointing to the address of num2. So P1 holds that address, right? The value of P1 is a pointer to this address, and it's pointer to this. P2 is a pointer to this address, which is num1 and num2, the addresses of num1 and num2 respectively. Okay, so P1 and P2 are pointing to these addresses. So how do we actually access the values at that address from P1 and P2? So this is where we can use what's called the dereferencing operator, which is the same asterisk. So we can say cout end line, cout. So we use this dereferencing operator, star P1. So this is actually going to give you the value at the address that P1 is pointing to. And same for P2. This is going to give you the value at the address that P2 is pointing to. So if we were to run this, and there you go, you get the value at the address that P1 is pointing to, which is 10. Because remember, P1 points to the address of num1, and num1's value is 10. And same goes for P2. This is pointing to the address of num2, which has the value 25. So that's why this dereferencing operator gives you the value at the address P2 is pointing to. Okay. So now what if we did this? So what if we now assign P1 star equals to P2 star? So what does this mean? It's good to kind of take a second and think about what does this actually mean. Oh, sorry, let's make this P star. So what does this mean, right? We have the same dereferencing operator. So we're setting the value that P1 of the address that P1 points to. So that the value at the address that P1 points to is going to be equal to the value at the address that P2 points to. Okay, so that's what we're doing here. So we're reassigning the value at the address that P1 points to be the value at the address that P2 points to. Okay, so we're changing the address of the value that P1 points to. All right, so if we were to print out, let's first print out cout. We're going to print out what we're doing. Okay, so we did this operator. And so first let's print out num1 again. Okay. And we'll print out num2. Okay, so think about what should this have changed, right? So num1 and num2, did they actually change? Well, let's think about it. P1 points to num1, and we're changing the value at P1. Okay, so that means we're changing the value of num1 because P1 points to the address of num1, and it's changing this dereferencing operator saying we want to change the value at that address, the value at num1, to be the value at the address of that P2 points to, which is num2. Okay, so we're actually assigning num1 to num2 indirectly, right, through this dereferencing operator. Okay, so what we should see here is that num1 is now 25, right, because the value at the address that P2 points to which is the value at num2, is 25. So now num1 is 25 because P1 is pointing to num1, and we're changing the value at that address. Okay, so we're changing the value of num1 to 25. So let's run this. And there you go. Okay, so you'll see that num1 and num2 are both now equal to 25. Okay, so what if we did this instead? What if we changed, let's comment this out, comment this out. What if we just changed the address that P1 points to? So now we're saying P1, the pointer P1, is now going to be equal to the pointer P2. So we're basically setting, this is the same thing as setting, same thing as P1 equal to the address of num2, right? Because P2 points to the address of num2. So now we're assigning P1 to point to num2, the address of num2, and P2 still points to the address of num2. So now we have two pointers pointing to the same address. Now the question is, does this actually change num1? No, num1 still has its own address and its own value, right? So P1 now just doesn't point to num1 anymore, it points to num2. So let's show what num1, num2 is, and let's also output the address, the new addresses of P1 and P2. Okay, so we're going to print out P1 and P2. Okay, so let's run this. Okay, and now you can see that P1 and P2 are pointing to the same address, right? And that address was the address of P2. So P1 is no longer pointing to num1, the address of num1. It's now pointing to the address of num2. So that's why these two are the same, and they're both the address of num2. Okay, and notice the value at num1 did not change. It stayed the same because we didn't do anything to the value of num1. Num1 still has its own address, which is this here, and it still has its own value. We just changed what P1 is pointing to. So you can think of it as an arrow pointing to this address. Right now, instead of pointing it to address num1, we're pointing it to the address of num2. So anything we change to, if we try to change the value at P1, we're also changing the value at P2 because these point to the same address. Okay, so it's important to understand what's going on there. Okay, so given that information, now let's actually use a function that computes the hypotenuse, right? The square root of x squared plus y squared, the two sides squared. Okay, so this is find h. We pass in the x and the y value, and we should return the hypotenuse. So here's the function defined here. And notice that we're passing in the address of the value, right? So we're not actually passing in the value itself. We're not passing in a copy of the value. We're passing in the address, the value directly. So anything we modify to these arguments being passed in, they're going to actually modify it in the main program as well, not just in the function. Okay, so that's the purpose of passing by reference. Okay, so let's actually do this. So if we say cout find h, and we're going to pass in num1 and num2, and then we're going to output. So we're going to output the result, and we're going to output what happens to num1 and num2. Okay, so let's run this. Okay, so there you go. So you see here you go, we printed the hypotenuse as we wanted, but notice it also changed num1 to now 10 times 10, which is 100, and changed num2 to 25 times 25, which is 625. Okay, and the reason it did that is because in the function, we actually modified the values here. Okay, hope this makes sense. If you have any questions, please reach out. Thanks.